Alright, yeah, so welcome to our second workshop. Today's topic is advanced multiplication in series. So this is the first day we'll actually dive into a new concept for advanced workshops, and then at the end, instead of playing a Kahoot like last time, we're going to try our new practice game.
So to start out, today we're going to be looking at FOIL with 2 digits and 3 digits for a faster way to multiply in your head. And then we're going to talk about Fibonacci numbers, which might be new for some people. And then we're going to talk briefly about triangular and pentagonal numbers, if we have time. And then we'll probably run to the game.
Okay, so our first concept, multiplying 2 digits. So this concept, I would say this is probably the most important so far, because you can apply this to many scenarios, like not just 2 digit by 2 digit, but you can do 2 digit by 3 digit or 3 by 3. So it can be applied almost anywhere, and it's also pretty common on tests. So the method we're going to be teaching you for how to multiply any 2 digit by 2 digit is known as FOIL, which stands for first, outer, plus inner, and last. So basically, it's a sequence that goes in order. So looking at this model right here, you have 10a plus b times 10c plus d. And so now you want to just apply that first, outer, plus inner, and last rule. So your first in this case refers to the numbers 10a and 10c. And once you have your firsts of both binomials, just multiply them together to get 100 AC, and that's your first term. And so then you want to do outer plus inner. So your outer is 10A or 10A and D, and then your inner is B and 10C, 10C. And then you would just multiply them, so you have 10AD and then 10BC, but in here it's just the 10 is just distributed out, so it's the same thing. And then you want to do last, which is just the last digits B and D, and multiply them to get BD. And so once you have all your terms, you just put a plus sign in between, you're just adding the terms together. So this concept can be applied to just normal 2 digit by 2 digit multiplication. So for example, if you have 74 times 23, what you first want to do is look at the units, or the ones digit place, which is 4 and 3, and then you just multiply them together to get 12. Now, once you multiply the two numbers 3 and 4, you want to write down the ones digit number, but then save the tens digit number, the 1, for later. So basically whatever's in bold, write it down, and then whatever's italicized, the tens digit, just save it for later, and I'll tell you why. So now that we've done first, you want to do outer plus inner. So your outer is 7 times 3, or 3 times 7. Your inner is 4 times 2, so add them together and you get 29. But then you still have that 1 there. You still want to use that 1 and add it to the next, so in this case the tens one, because since ones in the units is a tens place digit, you have to carry it over to the next. So that's why you add the 1 back. So that's why the total sum is 30. And then do the same process again. Just write down the 0 and then save the 3 for later. And so now that we're on last, you just do 7 times 2, which is 14, and then add that 3 from the last step to get 17. And so when you have all this, your answer should be 1702, because first you wrote down the 2, and then you wrote down the 0, and then you have your final to be 17 with all the carried over digits added to.
Basically, I was gonna add that if you're to remember anything from FOIL, is just to remember this. It's because first, outer, inner, last. You don't have to worry about why it works if that's gonna confuse you. Just remember right here.
Okay, yeah, so here's another practice example. So if you have 85 times 78, just apply the same concept as above. So just multiply the units together to get 40, and then write down the ones digit, save the tens for later, and then do outer plus inner to get 103. So your sum, and just make sure to add in the tens digit of units, and then do last, and then make sure to add that. Oh yeah, so if you have a 3-digit number, so if you look at the tens one, since it adds up to 103, still write down the 3-digit or the digit 3, but then instead of having the tens digit, just do all the digits behind the ones digit. So add in 10 instead of just 0. And then yeah, that should give you, once you add up all that, you wrote down 0, 3, and 66, and so your answer should be 6630. Okay, so these are some examples for you to try. Uh, just go ahead and try them out and just put it in the math general discussion chat. Oh yeah, let us know if you want us to go back to the previous slide so that you can see the steps. Okay, yeah. So yeah, this concept's a bit hard, so it's fine if you didn't get it, but the answer is 1008. So just going back to the last steps, just, first do the units or the ones digit, multiply them, or, oh, this one's, I think we wrote it wrong, but it should be 4 times 2 to get 8. Yeah, just disregard 3 and 4. So it should be 4 times 2 to get 8. And since this one doesn't have any tens to it, you don't have to worry about carrying anything over. And so just write down the 8 and then do outer plus inner to get 20. And then you don't have anything to carry over. So you just do outer plus inner and then do the 100s place. So that's 2 times 4 to get 8. But then since you had that 2 to carry over, you want to add that to 8 to get 10. And then all you have to do is just combine all those numbers, 10, 0, 8 to get 1008. Okay, yeah, so try doing this problem using the steps in the first example. Okay, yeah, so we have one answer. Yeah, I think we can just go ahead and go over it. So, yeah, so first just start out with the ones digit, 3 times 5, 15. Carry over the 1 to outer plus inner to get 35. Write down the 5, and then carry over the 3 to the hundreds, or 3 times 5, to get 18. And then, yeah, so 1855. Yeah, good job.
So the next thing that we're gonna talk about is geometric sequences, and these are similar to arithmetic sequences. So yeah, they're similar to arithmetic sequences in that instead of adding or subtracting to increase the value, it multiplies to increase the value, and each term increases or decreases by a common ratio. The ratios can be any rational number, so as long as it can be expressed in a fraction, then it can be a common ratio. So here's an example. Find the common ratio of the sequence. So 15, 45, 135, 405, and 1215. So to find the common ratio, you take the second term of 15 and you divide it by the first term, which is 5, and you get 3, which is the common ratio. So another example with the numbers 75, negative 15, 3, and negative 3/5. So you would take the second number, which is negative 15, and divide it by 75, and if you simplify it, you get the answer of negative 1/5. So here are some examples that you can try. So this one is you have 256, 64, 16, 4, 1, and 1/4. So if you want to type it in like the general discussion.
You guys are really close, but think about the order of the sequence.
Yeah.
If I multiply 256 by 4, am I going to get 64?
Okay, so the answer would actually be 1/4 because if you divide 64, or if you take 64 and divide it by 256, then you get 1/4, and as well you can see that 1/4 times 256 is 64. So that's how you would find the common ratio. So if you want to try the next example, you have 1260, 300, and 1500.
Did anyone else get an answer?
And yeah, the answer is 5 because as you can see, the 12 is multiplied by 5 to get 60 and so forth.
Okay, on to a new topic. Sum of geometric sequences. So now that you know what a geometric sequence is and how to find the common ratio, you can use that to find the sum of a sequence. So sometimes on tests, they'll give you the sequence and then they'll ask you to add it up. So the easiest way to do this is to just use the formula where R is the common ratio and S is the sum you're looking for. So this is another way to represent a geometric sequence. A geometric sequence starts with a, which is the first term, and then it's multiplied by a ratio. So in the previous example, we started with 12, and then we moved on to 60, and then 300. So the first time it was multiplied by 5, which was the common ratio, and then by the third time it had already multiplied 2 times, so it was the ratio squared. And this is a way that you might see people represent geometric sequences in the future, and it goes all the way up to n minus 1, where n is the number of terms. So then, if you were to find an easy way to find the sum of the sequence without having to add up the terms individually, we can use a little bit of algebra to kind of resequence it and find the formula. So if we divide everything by multiply everything by r, you can multiply a by r, ar by r, and then it seemingly shifts the whole sequence over by 1. So then now we can if we simplify this further, we can get s minus r times s, which is equal to a minus times r to the n. And then once you divide that out, you can get s is equal to a times 1 minus r to the n divided by 1 minus r. You don't really need to worry about this. If you can derive the formula on your own, that's great. But I think the most important thing for now is just for you to memorize this formula, because you probably won't have that much time to think about the formula if you're on number sense. So the sum of a sequence is the first term times 1 minus the common ratio to the power of how many terms you have in the sequence divided by 1 minus the common ratio, where the common ratio is always a fraction. So if the sequence in the previous sequence where we had a 5, you would have to flip the sequence backwards so the common ratio could become 1/5. And then you can use this formula, which is what happens here. Okay, so here's an example. If you were to find the sum of the sequence 125, 405, plus 135, plus 45, plus 15, plus 5. So if you notice, the common ratio is 1/3 because each term is multiplied by 1/3 to get all the way down to 5. So then if you apply the formula, you can take the first term, which is a, and you multiply it by 1 minus the common ratio. The common ratio is 1/3, and we have 1, 2, 3, 4, 5, 6 terms. So you can minus 1 minus 1/3 to the 6 times 1 minus 1/3. So then once you solve, you get 1 minus 1 minus whatever 1 over 3 to the 6th power is. And then once you simplify, you get 728 over 729 divided by 2/3, which is 1 minus 1/3. And then if you simplify further, you'll get 1,820. This seems kind of complicated, but usually on a number sense test, they won't give you ones this complicated, so it'll be easier for you to solve in your head. But for the sake of an example, we chose one that was slightly larger. Okay, so here are more examples. And I think that I'm going to let you guys try this on your own first and see if you can do it. So 3/5 plus 3 plus 15 plus 75. Give it a shot and see if you can figure it out. If you need me to go back to the formula, let me know and I can also do that. Okay, since no one has said the answer yet, I'm going to go ahead and go over it. So if you look at the sequence, we see the common ratio is 5, right? But the problem with that is that we can't use a common ratio for this formula that's above 1, so we have to flip the sequence. So it becomes 75 plus 13 plus 3 plus 3/5. And now we see the common ratio is 1/5, and that makes it a lot easier to solve. And then since fractions are really hard to type on there, I'm going to go ahead and just write it out on here. So if we have the common ratio, so once after we flipped it, the first term becomes 75 right here. So then with the formula, A is 75, and we multiply by 1 minus, and then since the common ratio was 1/5, we can raise 1/5 to the, depending on how many terms we have 4 terms here, so we'll raise 1/5 to the 4th power. And then on the bottom, we'll subtract 1 minus the common ratio. And that will give you your answer. And if you simplify this out, you'll get 75 times 624 out of 625 divided by 4/5. So then once you multiply that out, you'll get 31 out of 125. And if you multiply that by 75, you'll get 3,000. Oh, wait, no. That doesn't seem right. Let's see. I'm going to double check that because it doesn't sound right. Okay, 93.6. And the 0.6 is accurate because if you remember, we had a fraction in our sequence. Okay. On to the next.
Okay, so this is sum of an infinite geometric series. So it's similar to the finite ones, but I think this one might be a bit easier since the formula is shorter. So the formula for this is a1 over 1 minus the common ratio. So a1 meaning the first term divided by 1 minus the common ratio. Okay, yeah. So yeah, A1 first term, R is a common ratio. Explanation. So this formula limits the sequences. I think I don't know exactly how to explain it, but it limits the sequence and until it approaches a certain number.
Oh, can I talk about this for a
Yeah,
moment
yeah.
then? Okay, so the way limits work is in this case that eventually your number will get so small that it'll get really, really close to 0. So if you've ever been in algebra, sometimes you'll learn with exponential decay, the line will approach 0, but it'll never quite reach 0. So that's kind of the case with infinite geometric series. So in our last example, we had 75 down to 15 down to 5, and the fraction would keep getting smaller and smaller. So the fraction you add would basically be close to adding 0. So there's a max where the sequence event eventually just caps and it'll never go above that number. And that's how we can find the sum of an infinite geometric series. And that's how limits work. It's kind of the limit of where it stops.
Alright, yeah. So for an example, you have a sequence 9 plus 1 plus 1/9 plus 1 over 81 plus 1 over 729. So your first step would just be to try to find the common ratio or the first term, just so that's 9, and then you want to note what the common ratio is, which is 1/9, and then you want to just plug in those numbers in the formula. So that's a1 9 divided by 1 minus the common ratio, so 1 minus 1/9, and that'll give you 9 times 9 over 8 to get 81 over 8. Yeah, so this one's just plug and chug in the values and you should be able to get your answers easily. And then so for another example, you have that sequence right there. And so just first note whatever the first term is, note the common ratio, and then just plug it in the formula, and then you'll get your answer.
And if you're wondering where the formula for this is derived from, it's using the previous formula for a finite geometric series, but you can eliminate the subtraction because that number eventually is going to get so small that it's just going to be a1.
All right, yeah. So go ahead and try this problem with the same formula before. And then in case you need it again, it's just the first term divided by 1 minus the common ratio. Okay, oh yeah. Oh wait, Olivia, can you go back to the problem? Okay. Okay, yeah, so if you have one answer, yeah, let's just go over it then. So yeah, first just keep note of your first term and ratio, and so that's 16 and 1/4, and then just plug it in the formula to get 16 times 4/3 to get 64/3. So I think yeah, you got it right. It's just that was just an improper. So yeah, good job.
So another sequence is Fibonacci numbers. So this is a really cool sequence that has a lot of relation to nature, but I'm not going to go into that. But I do suggest looking it up. It's a very interesting topic. It's very common on these tests from. It's really common on the UIL tests. It's a recursive sequence. It goes on forever, and so how it works is it goes 0, 1, 1, 2. So basically, you get two numbers in a sequence, you add them, and that's the next number. And then you take the last two numbers. So let's look at this. So 0 plus 1 is 1. And then you have another 1. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5, and so on and so forth. So a question might look like, what's the fifth number of the Fibonacci series? And that would be 5. Yeah. And then another question could be, what's the sum of first 7 Fibonacci numbers? So how you do this is, so you have 7 ones. So ignore the 0. I don't think we're counting the 0. So for the first 7 Fibonacci numbers, you see, so you're adding, you have 7 ones, and then you have 7 ones again. I mean, no, you have 7 ones, you have 6 ones. Actually, can I get a whiteboard? Like, can I share my screen? It's easier to explain visually.
Screen once he shares. And something to note before he switches over, the reason that you don't count 0 as the first number in the sequence is because it's usually referred to as F0, which is kind of like before the sequence starts. So usually when they say the first number, it's usually 1.
I'm still getting a whiteboard.
You're
Just a
fine.
second. So, here, I'm gonna share my screen.
Okay, and then once he starts sharing his screen, you guys can go ahead and stop watching this one and then go watch his.
I'm just gonna use a notepad if that's fine instead of a whiteboard.
That's okay. Did you start sharing?
Oh no, not yet. Discord's kind of lagging out for me. There we go. Okay. And yeah, there we go. Okay.
I don't see a screen share. It doesn't tell me that you're like sharing.
Oh wait, it's so Discord seems to be really like laggy on my end. Is it okay if I like quickly restart it or something?
Yeah, sure. Do you want to just try to verbally explain it then?
I'd prefer to have like some sort of visual, except I can try here. So find the sum of the first 7 Fibonacci numbers. So you have 1, which is basically the starting number, and then you have 1 again, which is the second number. So 1 is 1 plus 0. Then you have 2, which is 1 plus 1. So at 2, you have 1 of the first one, and then 1 of the second one, right? And then for 3, it's a sum of... Oh, wait, it says I'm disconnected.
Oh, you're still here, and I can hear you, so just keep
Okay,
talking.
that's good. Yeah, so the stream died on my end. Fun.
Right, we can come back to this. For now, just like because that method is probably going to take a visual representation. For now, just think of the first 7 numbers and then add them because that's how most people do them anyway. And that would get you 33.
So the stream came back.
Okay, so while he's like while his like thing loads, you guys can go ahead and try this one. Find the 8th number of the Fibonacci series.
Yeah, it starts at 1.
Yes, it does start at 1, Iris. So the first 3 numbers would be 1, 1, 2. So don't count 0. It's just usually seen whenever you write it.
Okay, sorry, I'm back.
All right. Let's check. If no one else has an answer, I'm going to go ahead and go over that. So the answer is 13. So I think you went over by 1. Try the next one. That's okay. You're pretty close. It is 143. So I think you might have also added 1 more this time. Or somewhere off. But the answer is 143. So okay. Here's something really interesting about the Fibonacci sequence. It's not really required on tests. This is just something extra to think about, because sometimes if you go, I believe if you go to math in other places, like outside of school or maybe college math, they'll mention the Fibonacci spiral, which is an approximation of the golden spiral. And I know Ramesh mentioned earlier that the Fibonacci sequence occurs in nature, and this is kind of an example of it. This isn't quite nature, but it's seen in natural phenomenons. So it increases at every quarter turn, and it's an infinite pattern that goes on. And it'll repeat over and over. I just wanted to mention that this isn't going to be on any of your math UIL tests, but it's something interesting to look at. So basically you start here, and it starts with the Fibonacci sequence. And each of these numbers is the side length of the square, and it continues on and on. So if we see here, this is a wider view of it. It just continues on infinitely. And sometimes I think mathematicians today still sometimes study this because it's a pretty interesting concept to where it just works out perfectly.
Okay, yeah, so some more ways Fibonacci values are used. So this is called a Pascal triangle, and you guys, I'm not sure if it's on the test or not. I personally haven't seen it, but I know it's a concept in Algebra 2. So whenever you guys get to that class, you'll see this concept. And so basically it's the sum of slanted lines. So if you look at all the red lines that are drawn in the diagram, you would just take the sum of whatever red line, whatever the red line touches. So like 1, 1, and then 1, 1, 2, and then so on. Okay.
Okay, so we're gonna do something different for this. We're probably going to have you guys just work together to kind of finish a math number sense, right? Laksh is going to screen share, I'm guessing.
Yeah, I can screen share.
All right. So basically, we're going to give you guys a number sense test, and you guys are going to work together to see how many you can get done under a time limit.
Yeah. Oh wait, Olivia, can you paste in the shared document in the chat? I think it's in the slides, the last.
Give me. Yes, I can. Okay, so everybody go to this document and then be ready to start answering the questions that are going to show up on the screen. Okay, I'm going to give y'all 10 minutes and see how far you guys can get together. Your time starts now.
Oh wait, here, could you pause the timer for a second?
Oh, yeah.
Okay, yeah, so it is a team thing, so go ahead and like unmute. That way you guys can talk to each other. And since it's number sense, make sure to go in order of the questions. Like, so for example, you don't just like skip to the very last or something like that, because it'll be a penalty, because since in the actual number sense scoring, if you skip a question, you lose points. So just treat it like a normal exam. You guys can use each other for help. And so just number the questions in the document and then write in the answers for each.
So the questions are screen shared. And you guys only need to try the first 20. We'll do A plus math next time. But for today, we can do number sense. Oh yeah, and in this case, since there's multiple of you working on one test, it's probably smart if you actually do jump around because you guys don't want to all be working on the same problem at the same time. That's fine. Go ahead. Bye. You have 2 minutes left. Okay, time is up.
Okay. Okay, so yeah, nice job. You got to 14. That's pretty good. So yeah, now we can grade it. So
Wait, Loksh, can you hear me?
oh yeah, I can hear you.
Okay, time is up. I don't know if you can.
Yeah, I think you
My
said it.
computer.
Yeah.
Okay, my computer said I got disconnected, so I wasn't sure if anything was still like.
Okay. Yeah,
But
we're
yeah.
reading it now. So yeah, you got the first one right. And then the second one also you guys got right. Oh, third one you guys got right. Uh, got it. Yep. Mm-hmm. Yeah, so for number 10, it was like the range question. So as long as you get it in within the range, you have it right. Yep, yep. Nice. And then, okay, so it says number 14 is 16. So, okay, yeah, so number 14, just make sure to like apply order of operations. So just first do 16 divided by 4. So that's 4, and then add it to 12 to get 16. Right, yeah, but good job. So scoring, as far as scoring goes, so it's 5 points for every correct, and then four for every incorrect or skipped. So you guys got 13 correct, so that's 65, but then one wrong, so that's -4, so that's a score of 61. So that's pretty good for a first time. So yeah, now like it seems like you guys have the content down, but it's more about the speed. So just by practicing, you can develop that speed.
That's all for today. See you guys next week.